Hi guys, uh, welcome back to the channel after a long time. We are going to try a little bit more complex puzzle called Killer Counters by Burak Alver. If I haven't butchered that name, I'm not sure. This one has a lot of restraints apart from the normal Sudoku rule. So first of all, the normal Sudoku rules apply, which is that you must have within each box, within each row, and in each column the digits 1 to 9 without repeat. You have a killer cages constraint, which means that every cage, this is the dotted line in the outside, must sum to the total that is given in the top leftmost corner of that cage. You have crop T dots, which mean that there are two types of crop T dots. First of all, white crop T dots, which is this. This is a consecutive pair. Name this is a one. This is a two. This is a two. This could be one or three. This is three. This could be four or five, so on and so forth. And the black crop T dots, which means that one of the digits is double the other. So if this is a one, this is a two. If this is a two, this could be a one or a four. If this is a three, this is a six. If this is a four, this is an eight, or it could be a two as well. There's no other pairs that work actually because 5, 7, and 9 all do not have doubling or half options available within the integer set. So these are the options available here. Black, not all dots are given, which means there's only positive information is given. There is no negative constraint, meaning this is it's absolutely fine for this to be a consecutive pair. But there, um, it, this is definitely this could be a you know consecutive pair or a doubling pair, but this is definitely a consecutive pair, as I say. So this is what crop T dots mean. Sorry, I was just reading the other constraint through just to make sure what I'm saying is correct. So yes, there is only positive information. There is no negative constraint, meaning it's absolutely fine for this to be consecutive or doubling. What else is there? Counting circles, which means that every digit, a circle digit indicates exactly how many circles contain that digit, meaning if this was a 7, means that within this grid, there are 7 sevens within the circled cells. So those are all the rules. Let's give it a go. I'm going to restart my timer just to see how good we do. Okay, let's give it a go, guys. Okay, first thing first, I see a 16 cage here, which is very forcing. This can only be 7 and 9. And this does give me one very important thing right away, which is that this has to include a 9, which means because there are only 9 nines within the grid, in every box, the 9 must be within the circled cells. So, for example, the 9 here must be within the circle, in this box must be within the circled cells. So, this is a 2 9. So, now we know 7, 2, and 9 are included in the circled cells. 2 will be twice, one is here, and then there will be another 2. There will be 7 sevens that will be circled, and then there will be at least 9 nines circled. We'll see what other digits there are. So let's go with nines first because they are the most forcing. As I can see, 9 here. In this box also the 9 has to be within the circles. It's not here. So this is the 9. Within this box, the 9 is here. Within this box, the 9 is here. It could be anywhere in this box. It's specifically in these three. It could be in any of these. Actually, it couldn't be here. So it is here only. So if it is here, it's not here. So this is the 9. So these are not 9s. What else? Whatever in this box, actually you could have it anywhere. So all of these could be 9. Interesting. When I have the 9s here, that means this is not a 9. Yep. So this is a 2 and this is a 9. Okay. Interesting. Okay. So let's check the sevens again. Now the sevens must be, why is that important? Because as you can see in this box, the seven is not within the circles. In this box also, the seven is not within the circle cells. So every other box, the seven must be within the circle cells. So the seven is here, so the seven will be here in one of these two. If this was seven, this would be four. Let's remember that this is actually 479. So let's mark that up. And this is not the nine. The nine, clear 5 9 marks. The seven is within this plethora of the cells and here. So this is also forced now. 9 7 is 16, so this must be 5 and 7. That's interesting for 7 right away within this column because the 7 cannot be here. It's in the cells. It's not here, so it's in the circle cells. It's not here. It's not here because of the row. So this is your 7. Okay, let's continue with the 7s within the cells. The 7s are not here. Either this is a 7 or this is a 7. And in here, you could have a 7 anywhere actually. Okay, now there is another trick that we can do with the circles, by the way. If we count up all the circles, it would give us a total of, because the circle digits can only be as many times as they are within the circles. So if all the digits 1 to 9 were within circles, you would have 45 circles. How did I get to that? Because every digit from 1 to 9, if you sum them up, 1 plus 2 plus 3 plus 4 all the way up to 9, you would arrive at 45. So if 1 to 9 are 45, if you have the number of cells, you can find how many number of cells you have, then you would be able to tell which digits are missing. So let's try that. For example, in this box, you have 5 cells which are circled: 10, 13, 15, 18, 21, 22, 24, 26, and 31. Okay, so you are missing 14 sums worth of digits that are not in the circles. I know the 8 is not there. How did I get to that? Because you can see in this box, the 8 is not in the circles, right? In this box, the 8 is not in the circles. And you must have 8 also here and here. It's not there. Here is not there. So you have one, two, three, four, 5 boxes where the 8 cannot be within the circle cell. So you can have a maximum of 5 8s. That's not correct. You must have 8 8s if you're going to put even one 8 in the circles. So we know 8 is missing. Now we know 6 worth of digits are missing. So it could be either a 6 itself, okay, or it could be 1 5, which is not possible. We know 5 is in the circles, or it could be 2 4. That's also not possible. We know twos are in the circles. So it is 6 and 8 that are missing from within the circles. So we know you cannot have sixes and eights within the circles anymore. That's what this means. Every other digit must be within the circle. So there will be one ones, two twos, three threes, four fours, five fives. There will be no sixes. You will have seven sevens and nine nines. So this is how your 31 cells are coming up, right? So let's see how that helps us. So 11 could be 29. That's completely fine. It couldn't be 38 because of this. You can't have eights. This I just wrote down what is missing. I mean, this does not mean this cell has to be 6 or 8. I just wrote down which digits are missing too, so I can remember. So this cannot be 38. This cannot be 5 6. So it is either 2 9, which can be either way, or it is 4 7. And the 9 is here. The remaining cells that are missing are summing to 9 itself, right? So you could have 9, you couldn't have 918. So if this is, for example, 9, you can't have 1 8. You could have 2 7, but in this specific order, this would be 7. This couldn't be 2 because then you would have unlimited, you could have taken off both the options for it. So this would be 9 and this would be 2 in that scenario. So this would not be 9 in that scenario. So you could have this, um, which does work for this 8 cage as well, right? So because if you take You can't have 1 7 because 7 is here. You can't have 2 6. You could have 5 and 3 here. Let's write that down actually. So in this scenario, this word, this is what the options would look like. You could have 9 with 7 here, 9 here, 2 here, in which case this would be 3 and 5 in this order specifically. So what were the other options? It could be 972. It couldn't be 918, what you said, because the 8 is not there. It can't be 936 either because of this. It could be 945, in which case this would be 5. This would be 9 and 4, like this. And in this scenario, because this is 4, 5, and 9, this would be 1, 7, because you can't have 3, 5. Why don't you have 2, 6? Oh, because the 6s cannot be in circles. So you can't have 2, 6 anyway. So it's either 1, 7 or 3, 5. So since the 5 is here, so this would be 1, 7 in this specific order. So these are all the options. So the 2 option is a little bit interesting because if you were to put, you couldn't put, you don't have the 2 option. How did I get to that? Let me show you. If you were to put 2 here, remember you can only have two twos in the circles, right? So if you were to put this as, actually that doesn't work in itself because then, as you said, this would be 7, 2, and 9, right? So if you were to put 7, either 9 or 2 here, you wouldn't have any options left for this because you can't have 2, 9 now because this is either 2 or 9. You can't have 4, 7 because this is 7. So this is not 7, 2, 9. So this is not 2 or 9. So this is 4, 5, 7. Sorry, 4, 5, 9. And the 5 is here, as we can see. So this is 5. In which version this was 7 and 1. So this is 4 and 9. This is 4 and 9. So this does not include the 2. And let's clean up the markings. Now this could still be 4, 9, the 4, 7 or 2, 9. We have had 2, 5. Let's actually count the 5s because 5s are pretty restricted in themselves as well. You can't have a 5 here. You can't have a 5 here. You can't have a 5 here, right? So 6 out of, you have a 5 here, you have a 5 here. You can't have a 5 here either, actually. So 1, 2, 3, and 4 boxes don't have 5. All other 5s in all of these boxes, the 5s must be within the circled cells. So this does include a 5 also. So the 5 is here, the 5 is here, which is right away interesting because the 5s now cannot be here, cannot be here, and so they are here. So this is actually a 5-7 pair. So let's clean up the pencil markings. Okay, so now you have 5 5s in the circles. 5 7 9, 5 7 9, 7 7. One of these two is a 7, which means this cannot be a 7 actually. Why? Because now the 7 is not here. It's not here or here. So it has to be here, but we know within this box it has to be here. You can also see that's from the rows. This is not 7, this is not 7, so this is 7. If this is 7, this is 5. So now we know 9 and 7 is 16, so this is 4. Actually, this has a very nice flow to it. Now I can see that 4s must be, then how do I come to that? The 4 cannot be here, right? It cannot be here. It cannot be here. These are 3 boxes that the 4 cannot be. It is not here. So you do have 3. Oh, you could have a 4 here as well. Okay, still, one of these two must have a 4 because there is a 4 here, there is a 4 here, and there is a 4 here. So you must have one more 4 only. So only one of these has 4. Okay, let's see. Actually, we can look here as well because this is a doubling effect, right? So you can't put 2 here anymore. because if this was 1, if this is 2, it would require a 1 or a 4. This is the black copy dot. Remember, 1 is double the other. So this cannot be 1, 2. It cannot be 2, 4 because the 4 is gone. It cannot be 4, 8 because the 4, 8, 4, 8 is gone. So this is 3, 6. So those options in, which make these two a 2 and an 8. Now this cannot be an 8 because this would need to be a 9 or a 7, and this cannot be 9 or 7. So this is 2, and this is 8. If this is 2 to be consecutive, since this is a white copy dot, it either has to be 1 or 3, and it cannot be 1. So this is 3. Okay, let me remove this because now this will confuse me. Do I remove this or do I take it somewhere else? Let's keep it for now. Let's see where this leads us. You can see the 5 is here, 3, 7, and 9. Oh, 7. Okay, 7 solves this. This has been available for some time now. Sorry, guys. As Bremser would say, it's not nice to shout at your screens. Okay, so let's see. What else can we do? So we have 1, 2, 3. We are missing 4, 5, 6, and 8. So this cannot be 6 and 8. So, I mean, this cannot be 7 or 9 as well. So let's clean up those pencil marks. Neither of these. Oh, okay, hold on. This is important because neither of these can be 7. The 7 must be within the. Oh, so this is a 4, 7 now. So this is not 2, 9. Let's take off the corner pencil mark. So 4, 7 means this is a 9. And this is a 4, which means this is a 4. So now you have 1, 2, 3, 4. Now you need 5, 6, and 8. And 6 and 8 cannot be within the boxes. Oh my God, am I glad I kept this award? So this cannot be 6 or 8. This is 5. And this is a 6, 8 pair. And remember, you had to have 9s within the circled cells. So this includes 9 also. So if this is 5, 9, it must include what else? 3. So this is 3, 5, 9. 3 and 9. Because this sums to 12. So this is 3, 9. So this is not 3. And this is 3. Another thing I was seeing was these are 9s here and here. So this cannot be a 9 anymore. Why is that? Because these are not 9s. These are not 9s. The 9 is here, and we know it's within the circle, so it's not here. And this 9 tells me it's not here, so this is the 9. So this cannot be a 9 anymore. This cannot be a 5 anymore. What are we missing here? Actually, we are only missing 1 and 2. So let's put them. 4, 7. These are from 1 to 6, 8. You know what would be hilarious? This actually does turn out to be only 1, 6 or 8. We don't know yet, but I'll put it in anyway. So we have 1, 6, 8, 1, 2, 6, 8, and this is also 1, 2, 6, 8. I'm going to remember now that 6 and 8 are missing. Okay, let's see. So we've had our 4 fours, so you cannot put fours, any more fours here. So fours are here along with the 6 and 8s. So let's put them in. So don't forget. You cannot have any more ones in the circles either. So this is 1, 4, 6, 8. Let's remove this and let's go to center pencil mark 1, 4, 6, 8. So you have, what do you have left? 2, 3. This is not 2. This is not 1. 2, 4, 6, 8. This is from 3, 5, and 7 only. Correct. So this is from 3, 5, and 7. So the 2 is here. Yes, and you could have seen that from here as well. The 2s are here. Okay, let's look for something else. The 7s are here. Would this be a 7? This would be a 600. Anyway, let's look at this row. What are we missing? 5 and 7, 2, 3, 6, 8. So let's put them in. This is 2, 3, 6, 8. So if this was a 2, this would be 1 or 4. It cannot be 4. it cannot be an 8 right away because there's no 7 or no. Oh, hold on. We're looking at the doubling effect. This couldn't be 8 because this is not 4. So if this was 8, this would be 4, so it cannot be 8. If it was 6, it would be 3, so this is not 6 either. If this was 3, this would be 6, so this is not 3 either, so this is 2. If this is 2, this has to be 1 or 4, and it cannot be 4, so this is 1. So this, and this are not 2's. Now let's look at this one. If this was 3, this would be 2 or 4. If this was 6, this would need to be either 5, which it is not, or 7. If this was 8, this would be 7 or 9. 7 option is already there. This gives me 4, 7, 9 triple actually. So this cannot be 4, 7 or 9. 9 it couldn't be anyway, so 5. Where does 5 go? It is here, and the 5 is, oh, you cannot put a 5 on the double. So the 5 is not here, here, not here, not here, and in this row the 5 is here, in this column actually, the 5 is here, so it's not here. Okay. So the 1s and 2s are here. This cannot, oh, what can this be actually? This cannot be 1, 2, you cannot put 8 here, so this isn't the, this is the 8, sorry. So this is not the 8, and this is a 3, 6. Now I can see the 3's aligning, means the 3 is not here, not here, not here, and here either. So this is the 3, and this is not the 3. What are we missing here? 2, 5, and 7. So this is 2 or 7. This is 2, 5, and 7. What I was seeing here was that the 7s are again limited to these. So these are not 7, these are not 7, these are not 7. So this is the 7, this is the 7, this is the 4, which means the 4 is not here. The 4 is vertical like this, so the 4 here is not in these cells. Okay, so 5, 7, 9, the 2 and the 3 are here. The 2 actually, where's 2? So the 2 is here. So these are not 2's in this box 5. The 2's are not here. The 2's means this is 2. So what is this? Let's find out. 2, 5, 7, 9, 1, 3, 6, or 8. So it's not 8. It is either 1, 3, or 6. These are from 1, 4, 6, 8. These cannot be 8. We'll see that later. I want to finish this row first. 1, 2, 9. We are missing 4, 5, and 8. This is not 5, so this is 4 or 8 only. This is not 5, so, and not 4 either. So this is 8, 4, and 5. That was interesting, which means this is not an 8. Neither of these are 8 actually. So this is the 8, which means these are not 8. And this is 1, 4, 6, which means this 3 and this and 8. What are we missing here? We're missing 1 and 6. So this is 1, 6. These are not 8s. This is 4, 7. Okay. Now let's look in this column. This is 9. We're missing 1, 2, and 5. This is not 2 or 5. So this is the 1. This is the 2. This is the 1. And this is the 5. So these are all not 1s. This is 2, 6, 8. Okay. 1, 2, 3, 4, and 4 means this is the 4. This is the 6, and this is the 8. So this is not the 8. The 6 means this is the 6. This is the 6 and 3. So this cannot be a 4. This is the 7 and 4. This is the 7, making this the 7, this the 7, this the 5, this the 5, and this the 2. Okay, so these are not 7s now. Let's clean up the pencil marks. This is not the 1 anymore. So this is not the 1. Do we see anything else? Not really. 3, 4, 6. Okay, something will resolve this for sure. 4, 7, 9. What are we missing here? 1, 2, and 8. 8, 2. The 2 is here. The 8 is here, and the 1 is here. This should give us a 1 here, the 6 here, the 8 here, the 6 here, and the 4 here. Now, the 6 tells me this is 6 and 3. This is 3 and 9. This is 9 and 4. Okay, so this should be Sudoku from here on out. We are missing a 1, so the 1 is here. We are missing 2 and 3. I'm sure this one will disambiguate everything in the end. But let's keep going with the Sudoku for now. 2, 4, 7, 5, 8, 9. We're missing 1, 3, and 6. So this is 3 and 6. This is 1, 3, or 6. 2, 3, 6 in the column. This is the 8. This is the 8. And this is the 1 or 6. Okay, I'm sure this is the one that's going to disambiguate everything. Did we have 2 2s or 3 3s? I can see 1 3 here, 1 3 here, 1 2 here, and another 2 here. So this cannot be 2 because you've already had the 2 2s, and this will disambiguate everything. So this is the 3, this is the 2, this is the 6, this is the 2, this is the 6, 1, 6, 1, and 3. There you go. Did pretty well. It was a good puzzle. Hope you guys liked it. Like and subscribe, guys. And let me know if you want me to do more variant Sudokus. This really sharpens your mind and makes you think outside the box, this kind of constraints, you know. Normal Sudoku is a little bit, it's pretty straightforward for me at this point of time. But if you do something with such constraints, it should give you more, it should give you more, you know, thinking power in the long term. It should let you analyze things on the go, on the fly. These new different type of rule sets. In Logic Master Germany, I just logged on the other day. I want to give credit to Simon and Mark actually from Cracking the Cryptic. They're the ones who got me into Sudoku in the first place during COVID time. Since then, I've just been, you know, I love this game, and this has sharpened my mind over time in the long term. This lets you think more critically, more outside the box. I hope it does the same for you guys. Let me know you liked it, guys, and let me know if you how you went on as well. If you did any better than I did. Good luck and happy solving.